Hi everyone. I should just mention my name's Gerrit Lane. I'm one of the dynamics engineers at Experior Laboratories. Here today to talk about demoing, I guess, high G dynamics testing. Dynamics incorporates vibration, shock, pyro-shock simulation. We're starting here with the list of the shakers that we have in our Vibe Lab. And this is a growing list. Anyone who's used UD shakers knows that they're the best. And each of our T2000s has 3-inch stroke, which lets you get those high G shock profiles and very high displacement tests for windmilling. They've each got a 240 kVA amplifier to let us hit hard to reach random profiles. If you see our levels down there, these are the max levels that we've reached. We've gone a little bit past these. Obviously that depends on the payload, but some of these are actually a little higher than what the shaker manual is rated for, and I'll go over that a little bit in a second. First, let me give you a picture of what our Vibe Lab looks like so you can see where all these shakers are situated. 3 T2000s over there. We've got a chamber so you could do combined environmental testing. A large 48 by 48 inch head expander. We've also got a 2-ton gantry for large payloads. And one of the neat things about this room is that all of our shakers can be mounted on air casters and moved around the room for large payloads. So we've done some work, and there's a video coming up in a little bit of some kind of crazy payloads that we've done. First, let me talk about. I guess this is one of the random vibration profiles. Anyone who's familiar with vibration, it's a 175 GRMS test, and it's got a lot of narrow band energy. This has a huge current draw on the shakers, and it's really hard to reach without band splitting. But we reach it through the use of proprietary fixture design. And we spec all of our levels up to 2,000 hertz. We've gotten requests for 3,000 hertz. We could do that too. We just haven't rated ourselves to those levels. So here's kind of a simplified image showing how we go about designing fixtures for these high-level tests. You've got a plate here, and it resonates at a certain frequency, and that gives you a boost. If you're inputting energy at the outer corners of the plate, you're going to get more energy out of the center of the plate. Based on the weight of the payload and the stiffness of the plate and material used, you're going to get a different response, and you can use that to your advantage to kind of get rid of dead zones in the shaker profile and hit levels that you could otherwise not achieve. So for each test, we'll make a custom fixture for high-level tests at least. Here's an example of that. This is a high G level Orion spacecraft test that we did. We achieved it through the use of a special bolt pattern. So the way that this plate's actually fixed down to the shaker, we optimized that for where the energy in the band of this vibration was. I can't tell you how high the levels are, but they're very high. Thanks to Hyrel and Kern for the connector. Okay, going back to extra large payload solutions, you can see here, some of you might be thinking, why do you have a bunch of wood up on your shaker? Wood actually has a better specific stiffness than aluminum does. Believe it or not, it does damp out vibration, so it's a little hard to work with. But we designed this fixture basically within the constraints of the weight limits of our shaker. Custom designed it to fit this part, achieve this vibration program. It was very successful. So using the two shakers, let me go back there a little bit. Using the two shakers ganged together like this, each shaker has 25,000 force pounds, and when you combine them, you get double that. So you can get 50,000 force pounds on a test. You can also test larger articles. I mean, this is a little over 20 feet, you basically double the weight capacity of your shaker, and you also double the length, or you could go even longer than this if you wanted, I guess, just based on how much you want the middle to move. But yeah, we can fit some pretty funky stuff here. Okay, shaker shock. This is we use the same kind of principle. You can't really see it right now, but the way that we bolt this plate when we test it, it's essentially the same thing you would do to get those high G-level random profiles. You bolt the plate in a specific way, choose a specific thickness, so that you could take advantage of that plate's properties and reach shock levels that you couldn't otherwise. Here's a sample 5000 G SRS shock we did on the shaker. For levels that are higher than that, we do what's called pyroshock simulation. So this is essentially the same. If you've ever seen an SRS profile, which is that graph that we just had over here, defined as G's versus frequency. Spacecraft separation shock has really high levels, on the order of tens and 20,000s of G's. So to hit that, it's kind of not really achievable with the shaker. So we use mechanical impact. Same principle, you have accelerometers on the test fixture, so you know that the test fixture is actually experiencing those G levels. And we got a cool video of this going on too. So here we set up a high-speed camera. This is available upon request for customer tests if you want to look at sort of the destructive potential of testing. We actually filmed at high speed the shock impact on the connector, and you can see this all happens in tens of milliseconds. So you're not going to see this in real life, but you can see the way that the connector is moving, and you wouldn't notice that otherwise. So if you're ever having problems with a product or something, there are no problems with this one, but sample. So SRS shock is bidirectional. It's got acceleration in both the positive and negative direction. And so here's what a sample plot looks like for that. And basically that frequency profile is generated from this time history, so you get a plus and a minus shock at the same time. And if you look back at that video, you can see that the plate's actually moving. It looks like it's a very unidirectional shock, but the plate actually oscillates up and down. And so you actually get most of that acceleration in both directions. So you get both your positive and your negative shock at the same time. Here's one of our sample shock profiles from a very high level test we had to do. And I think that's it. Anyone have any questions? All right.